All right, so this mini lecture is going to look at the idea of nearsighted and farsightedness in the human visual system. So we are able to see well things close by and far away by the process of accommodation. And that process is covered in a different video. But real quickly, that's my lens and my ciliary muscles. If an object is nearby or at a location and the image is formed on the retina, so it can be processed by the brain, as I move this object further away, we know that with a refractory system that is converging, the image is brought forward. And under normal operations, my lens will thin and I will push that image back onto the retina so I can see it. But the question is, what happens if my lens can't thin enough? If my eyeball is such that my lens is unable to thin enough to get the image backwards. And this can happen if my eyeball is slightly elongated, where the retina is typically further away, that as I move objects farther away, I can't thin my lens enough to get it pushed back. Now, that's a problem in order to see things far away in clear focus. But is it a problem to see things close up? Well, if I bring this object closer, we know that the image is pushed back. And so close objects do have the potential to be focused on this elongated eyeball on a retina that's a little further away. Or my accommodation system can fatten the lens in an appropriate amount to get that image in focus. And so I am able to see things close by, but I'm not able to push that image far enough back to see things far away. Well, if I'm able to see things close by, this is what's known as nearsighted. When I am nearsighted, I can see things close. But as objects move further away from me and therefore further away from my lens system, they are pulled forward off the retina. This way, images pulled forward. They focus in front of retina, in front of the retina. And I'm not able to thin my lens enough to push them back. So what do? How can I get these rays of light to come together further away than they do in my normal refractory system? Well, in order for me to get these rays of light to come together further away, I need to have them coming in a little bit wider. If they come in a little bit wider, it's going to take a longer distance for them to converge, and therefore they have a chance of converging on my retina. So how do I do that? Well, I put a lens in front of my lens system that spreads the rays of light out, brings them in further apart, and they are able to refract appropriately. So for someone who is nearsighted, we use a concave lens to move the image back to the retina when my system can't accommodate. All right, so that's the idea of nearsighted. What if instead of an elongated eyeball, I have a squished eyeball? So let's go back to our normal eyeball, our appropriate for the lens refractory system that we have. We said with a normal lens refractory system, if I have an object and it is focused on the retina, what happens if I as I move my object further away, remember, we bring that object image up closer to the retina. Now, if I have a eyeball situation where I have a compressed eyeball. So the globe is a little more not elongated, but compressed, so that this is my retina, then indeed objects far away can be seen. But if I bring this object closer and the image is way back here, I cannot fatten my lens enough to pull that image up on the retina, so I need some help. So I'm able to see far, but I am not able to see near. This is what we call farsighted visual acuity. So what do? I need some help. I need some help getting that image brought in sooner and closer to the front. So farsighted occurs when images of near objects are too far behind the retina for me to accommodate. And I need help. I need to bring them in quicker. And how do I do that? Well, I put a lens that brings those rays in before they hit my system, and then my system can do it the rest of the way. So we use a convex lens to help bring the image forward to the retina when I can't do it myself. So that's our visual help. We use these glasses, these extra lenses, to help us. Now, how much help we need is dependent on the curvature of the lens. And that curvature is what defines the focal point. So when you get your glasses prescription, it's given in what's known as a power of the lens. And that really describes how curvy the lens is. So if I have a really curvy lens, I have a low focal point. The focal point is very close to the lens. If I have a very less curvy lens, a thinner lens, the focal point is further away. So as I increase curviness, I decrease the focal point, the focal length. Power is given as 1 over the focal length. So as I increase the curviness, I increase the power. Thicker, curvier lenses are for people who need more help getting that image on the retina, and they're a higher power. Power is given in what we call diopter. All right, so this is different than the power that we talked about with work and energy. And the unit for power, 1 over the focal length, is a diopter. Now, what about the two types of lenses? Turns out, by convention, a convex lens has a positive focal length. So, farsighted prescriptions have positive power. A concave lens has a negative focal length. And that's our convention. And so concave nearsighted prescriptions have a negative power. So that is how we fix our visual acuity using the help of lenses. Now I'm going to add one more piece to this idea of farsighted, because remember, it's about the shape of the lens that we are unable to get those images where they need to be. And in the case of farsighted, we aren't able to push those images further back. So, I'm sorry, we're back up. As the case of nearsightedness, we're not able to push those images further back, right? When an object moves further away. So we need help. We need to spread them out before they go back. And we can't thin the lens enough. Well, another way to fix this problem is actually not by use of the lens of the of an external lens itself. But if we could somehow change the shape of the refractory system, we could change where that image is produced and maybe get it within the range of accommodation. And that's what we do with LASIK. So LASIK surgery actually changes the shape of the cornea to change the refractory power of this system to get it within our abilities to accommodate. So this is what LASIK does. It actually shaves off, thins that cornea, makes it less curvy, so that we are now within the refractory power of our own system. So nearsightedness can be corrected through that method as well. All right, that's it for nearsighted and farsightedness and sort of that basic introduction on how we fix it. Good job.